Imagine a world so close to its star that its surface is a sea of molten lava, where temperatures soar above 2,000 degrees Celsius, and a single day lasts just 20 hours. This isn't science fiction. It's CoRoT-7b, a real exoplanet 489 light-years away, hiding secrets that challenge everything we know about planets. Discovered in 2009, it was the first rocky world beyond our solar system to have its size measured, a super-Earth that's tantalizingly similar to our own planet, yet utterly alien. What mysteries does this scorching world conceal? Could it hold clues to the origins of Earth, or even life itself? In this documentary, we'll journey through space and time to uncover what we know about CoRoT-7b and what still eludes us. From its fiery discovery to the cutting-edge science probing its depths, we'll explore a planet that defies imagination. Why does it matter? Because every answer we find brings us closer to understanding our place in the cosmos. So, buckle up. Let's dive into the enigma of CoRoT-7b. The story of CoRoT-7b begins not on its molten surface, but here on Earth, with a bold mission to peer into the unknown. In December 2006, the French-led CoRoT satellite, short for convection, rotation, and planetary transits, blasted into orbit. Its goal? To hunt for planets beyond our solar system by watching stars for tiny dips in brightness, a telltale sign of a planet crossing in front of its star. It was a revolutionary idea at the time, and CoRoT was a pioneer in the exoplanet gold rush. On February 3, 2009, at a symposium in Paris, the CoRoT team dropped a bombshell. They'd found something extraordinary. CoRoT-7b, orbiting a star in the constellation Rhinoceros, was unlike anything seen before. At just 1.58 times Earth diameter, it was the smallest exoplanet with a measured size, a rocky world, not a gas giant like Jupiter. The discovery electrified astronomers. Didier Queloz, a key figure in exoplanet research and later a Nobel Prize winner, led the team that confirmed its mass using the HARP spectrograph in Chile. Their verdict? CoRoT-7b was a terrestrial planet with a density eerily close to Earth's. But this wasn't just a triumph of technology. It was a turning point in our cosmic journey. Before CoRoT-7b, exoplanets were mostly massive gas giants, worlds too alien to imagine life on. CoRoT-7b changed that. It was proof that rocky planets, potential Earth twins, were out there. Yet its proximity to its star, a mere 2.6 million kilometers, raised eyebrows. Orbiting every 20 hours, it was locked in a fiery embrace, its day side a hellscape of lava. Was this a glimpse of Earth's past, or a warning of its future? The discovery built on decades of groundwork. From the first confirmed exoplanet in 1992 around a pulsar to the gas giants of the mid-90s, the field was ripe for a breakthrough. CoRoT-7b wasn't just a planet. It was a symbol of humanity's relentless quest to find our place among the stars. So, what do we really know about CoRoT-7b? Let's break it down. This super-Earth orbits CoRoT-7, a K-type star slightly cooler than our Sun, at a distance 23 times closer than Mercury is the Sun. Its orbital period? A blistering 20 hours, 29 minutes, and 9.7 seconds. That's a year shorter than a day on Earth. This proximity locks one side in perpetual daylight, with temperatures exceeding 2,000 degrees Celsius, while the night side plunges to minus 200 degrees Celsius. Picture this. A planet where lava oceans boil under a relentless stellar glare, and the air, if there is any, might rain molten iron. Its size and mass are where things get fascinating. CoRoT-7b's radius is 1.58 times Earth's, giving it a volume nearly 4 times ours. But its mass, that's trickier. Early estimates ranged wildly. Queloz's team pegged it at 4.8 Earth masses, while later studies, like one by Silvestre Ferraz-Mello, pushed it to 8. The current consensus sits at 6.06 Earth masses, with a margin of error. Combine that with its size, and you get a density of about 5.6 to 10.4 grams per cubic centimeter, similar to Earth's 5.5 or even Mercury's iron-rich core. CoRoT-7b isn't a fluffy gas ball, it's a rocky beast. But here's the kicker. Its composition is a puzzle. Is it a scaled-up Earth with a silicate crust and mantle, or a Mercury-like world dominated by an iron core? Theoretical models lean toward the latter, given its high density and star-hugging orbit. This could be a planet stripped bare, says astronomer Ignis Snellen. Its outer layers vaporized by stellar radiation, leaving a dense, metallic core. Others speculate it once had a thick atmosphere, now blasted away into space. The evidence keeps piling up. In 2011, the Spitzer Space Telescope confirmed CoRoT-7b's transits at different wavelengths, ruling out false positives. Its rocky nature was undeniable. But what about its surface? Models suggest lava oceans dominate the day side, with molten rock flowing like rivers. Imagine standing there, if you could, says planetary scientist Laura Schaefer. You'd see a glowing, fiery landscape, with the star looming 360 times larger than our sun. The night side, meanwhile, might be a frozen wasteland or a Terminator zone of eerie twilight. CoRoT-7b isn't alone. The system hosts at least one other planet, CoRoT-7c, orbiting every 3.7 days with a mass of about 8 Earths. There's even a hint of a third, CoRoT-7d, possibly Neptune-sized with a 9-day orbit. This crowded family raises questions. How did they form so close to their star? Did CoRoT-7b migrate inward, or was it born in this fiery crucible? Some hypothesize it's the remnant of a gas giant, its outer layers boiled off over billions of years. The climax of this story lies in its implications. CoRoT-7b isn't just a curiosity, it's a window into planetary evolution. Its extreme conditions mirror what Earth might have endured in its infancy, when our planet was a molten ball. Could studying it reveal how rocky worlds like ours take shape? Or does it warn of a fate awaiting planets too close to their stars? One thing's clear, CoRoT-7b is a cosmic laboratory, and we've only scratched the surface. Fast forward to 2025, CoRoT-7b remains a hot topic, pun intended. Today, astronomers are armed with tools like the James Webb Space Telescope and TESS, successors to CoRoT's legacy. Yet, this distant world still guards its secrets. Its mass uncertainty, 6.06 Earth masses, give or take, frustrates precise models. Was it always this dense, or did stellar winds sculpt it over eons? Current research leans toward the latter, with studies suggesting it lost up to 50% of its original mass to evaporation. The biggest challenge, its star. CoRoT-7's activity, flares and spots, muddies radial velocity data, making mass measurements a headache. It's like trying to hear a whisper in a storm, notes Exoplanet hunter Sarah Seeger. Still, advances in spectroscopy are peeling back layers. Recent papers hint at a thin, metallic vapor atmosphere, possibly rich in sodium or iron, condensing on the night side as liquid metal rain. While right, the trend is clear. CoRoT-7b is a benchmark for super-Earths. With over 5,000 exoplanets known today, it stands out as a test case for understanding rocky worlds in extreme environments. But its distance, 489 light-years, limits direct observation. For now, we rely on transits and simulations, piecing together a planet we'll never visit. The question lingers, what else is it hiding? What lies ahead for CoRoT-7b? The future is as uncertain as its past, but experts are buzzing with ideas. Over the next decade, telescopes like the Extremely Large Telescope could refine its mass and hint at its atmosphere, or lack thereof. If we detect even a whiff of vapor, says planetary scientist David Ehrenreich, it could rewrite our models of super-Earths. Imagine a planet raining iron under a crimson sky. Science fiction might become science fact. Long term, its fate depends on its star. CoRoT 7 will eventually swell into a red giant, possibly engulfing its planets. But before that, CoRoT-7b might erode further, shedding mass until it's a charred cinder, or it could stabilize, a testament to resilience. Some predict it's already at its limit, a relic frozen in time. Others see it as a stepping stone to finding Earth 2.0. Could its system harbor unseen, habitable worlds farther out? The bigger picture? CoRoT-7b is a trailblazer. As we hunt for life beyond our solar system, understanding hell's capes like this could guide us to paradises. Its secrets might unlock the story of how planets, and perhaps life, emerge from chaos. CoRoT-7b is more than a planet. It's a mystery wrapped in lava and starlight. We've learned it's a rocky super-Earth, scorched by its star, with a density that echoes our own world. We've traced its discovery from a bold satellite to today's cutting-edge science, revealing a place of extremes that defies comprehension. Yet, for every answer, new questions arise. What forged this molten marvel? What does it teach us about Earth's past or its future? As we gaze 489 light-years away, CoRoT-7b reminds us how vast and wild the universe is. It's a call to keep exploring, to ask the big questions. Are we alone? How do worlds like ours begin? So, next time you look at the stars, think of this fiery enigma and wonder what other secrets are waiting out there.